Hello friends, welcome to our channel. Let's have a look at problem 2929. Distribute candies among children 2. In this video, we are going to solve the problem using inequality. Right? Here the inequality means mathematical inequality. Right? So basically we are given two positive integers. One is n and the other is limit. So we want to find the number of ways to distribute these n candies to 3 children, such that no children gets more than limit candies. So here are two examples, right? And you can interpret yourself. Here are the constraints of the following. First, n is bounded above by 10 to the power 6, same as in same range for limit. So if you see this problem, maybe you know there are some combinatorial ways to address it, but that's actually not our purpose here. We want to solve it using coding way, right? So one thing that is related to this problem is the pigeonhole principle. So basically it says that if you have more candies than the boxes, then if you want to put all the candies in the boxes, then at least one box contains more than one candy. So here same thing. For example, you have n, you have limit, right? And you have a number of children, right? 3 children. If n is greater than 3 times limit, right? And then you cannot distribute that according to this pigeonhole principle, because at least one kid will get more than limit kids. So that's the one thing we need to notice. So next we want to solve it using inequality. So the question is that we want to find all the ABC tuples such that their sum equals to m, and each of them is in between 0 and limit. So because there are 3 variables essentially, so we can first fix 1. So we first assign to children C candies. So this C can be 0, can be 1, can be 2, then at most can be limit. But this number of candies we can assign to C is also limited by the total number of candies. If n is less than or equal to the candies, we can assign at most n. Therefore, the candies we can assign to C is this quantity, the minimum of n and limit, right? So once C is fixed, then there are n minus C candies, right? Then we want to assign to AB. So we can assign to B, so this amount of candies, 0, 1, 2. Then the minimum of the limit at n minus C, right? Then the candies left to A is n minus C minus B, right? And we need B is in this range, right? So we can have the two inequalities. First is B is greater than or equal to 0 and less than or equal to the minimum of the limit and n minus C. This is the one. Another one is that n minus C minus B. So this is the candies we assign to A should be in between 0 and the limit. So from 2 we can get B should be greater than or equal to n minus C minus limit, right? So also we require B is at least 0. Therefore B should be larger than the maximum of 0 and this quantity, right? And also we know B should be less than this one. So then if this number is greater than this number, then the number of possibilities is this number minus this number, then plus 1, right? You can understand this as the two ends of the closed intervals, right? And then this will be the solution. So I'm going to solve it using a for loop. So we have a result variable, and then for C in range, so min, limit, and n. So because we want to include this one, so we write a plus 1 here, because the range stops right before this number. if we plus 1, so the largest will be this number. That's what we need. And then if n minus c, this is the total candy we can assign to AB. So if this one is greater than 2 times limit, so using the same pigeonhole here, we cannot finish the assignment. In other words, we consider the case when n minus c is less than or equal to 2 times limit. So in this case, so you can actually derive this formula. So result is incremented by the possibilities, this one. So because here actually you can see if n minus c is less than or equal to 2 times limit, then you will get n minus c minus limit is greater than or equal to limit, right? So this one, let's see, if n minus c is less than or equal to limit, so n minus c would be less than or equal to, so this quantity is less than or equal to this limit, right? That's actually good. So once we have this, we just need to return the result variable, right? So let me first run it for a test. Yeah, it passes the 2 test cases. And then let's submit for the generic case. Yeah, it passes all the cases. So here the problem is that this solution is not the most general. If you want to understand better about the combinatorial things, so you can generalize this problem. So basically it will be, the general problem will be this, which can be solved mathematically. Generalization. So you have total amount. So you can assume it's a positive integer or just not positive integer. So you have, let's assume an integer, right? You have a limit, assign split into, say, k children. So what we want actually is let's call it A1, AI, right? So let's call say A1 up to AK, right? So what we want is summation of AI and AK equal to n, and for each I in between 1 and so here I'm using one indexing using the mathematical convention. So for each one we want AI is in between 0 and limit, right? So we want to find the number of ways. So this actually can be solved using mathematical combinatorics, but this is not our focus here. If you are interested, you can look at the some introductory combinatorics books. So with that said, I guess that's it for the current video. Thank you for watching.